All right, so in this video, we're going to keep talking about rational functions, but now we're going to talk about intercepts. So both x-intercepts and y-intercepts. So where do these graphs cross the axis? If they cross the axis, right? So we've seen, because of the different types of asymptotes that we have, that sometimes these graphs do not cross either the x or the y-axis, and sometimes they don't cross either. So that's a little wrinkle that we're going to have to deal with. But other than that, the process of finding x and y intercepts is basically the same for rational functions as it is for any other function. So if you think back to what we've done in the past for lines, for x intercepts of polynomials, of quadratic equations, of all these things, if we wanted to find x intercepts, we knew that we plugged in 0 for y, and then we just solved for x. And if we wanted to find y-intercepts, we plugged in 0 for x, and then we solved for y. So that basic procedure is universal. If you remember when we learned that procedure, that it had to do with just the nature of the points that are on the axes. And that nature doesn't change just because we're working with another function. So hopefully, as we get into this video and we start doing some problems, you'll find that it seems very familiar. The only real difference is that sometimes there won't be intersections. So sometimes you'll have no solution to the problems that you're solving. All right, so with all of that said as a preliminary piece of information, let's take a look at the learning objectives and let's get started. 2 learning objectives in this video, as you can probably guess: find the x-intercepts and find the y-intercepts. Those are our learning objectives, okay? And so as I said just a minute ago, we really already know how to do this. So let's start with the y-intercepts, okay? Y-intercepts. I usually like to start with those first because personally, I find that they tend to be a little bit easier. So we already know that to find y-intercepts, you plug 0 in for x and solve for y. Okay? So let's do an example where we do that. Example number 1, let's suppose that I have a function like f of x is equal to 3x minus 5 over 7x plus 12. Right? So there's my function. So we're going to plug 0 in for x and solve for y. And it might be helpful for you to remember that f of x, that is the same as y. Those things are the same. So really, that's what we're solving for, is that. Which means my equation already has y by itself. So when I plug in 0 for x, legitimately, all I have to do is just simplify that expression with order of operations. That's really all I have to do. Once I've got that simplified, I will already have y by itself, and so I'll be done solving. So order of operations with fractions, you might remember from when we did this last semester, that the fraction bar acts like a great big grouping symbol. So even though we can't see it, it is as if the top was in a set of parentheses and the bottom was in a set of parentheses. So we have to do those separately, and we have to do them first because grouping symbols come first in the order of operations. So in the top, inside of these green parentheses, I've got a 3 times 0 minus 5. So multiplication comes before subtraction. So I'll do 3 times 0, that's 0, minus 5. So I get minus 5 in the top. Then I do the bottom. 7 times 0 plus 12. Multiplication comes first, so 7 times 0 is 0, plus 12. 0 plus 12 is equal to 12. So I get 12 in the bottom. So that's what I do first. Then I try to simplify my fraction. But in this case, nothing simplifies. So that's just my answer. And of course, we know too, if this is like an SAT question or something like that, SAT doesn't require you to simplify your fractions. So even if this was like a 6 over 12, on the SAT, you could leave it that way and that would be all right. So this is the process for finding y-intercept. So that's a process that we already know. I do want to do one more problem of finding y-intercepts just so that we can see a unique thing that might happen with rational functions that we never ran into when we're working with lines and parabolas and stuff like that. So let's suppose that I have something like 5x, and let's say that it's over x squared minus 2x. How about that? Let's make the top 5x plus 1, 5x plus 1 over x squared minus 2x. There we go. So what I'd like you to do is find the y-intercept of that. We've already got the procedure. We've already got an example. You should have a basic idea. So pause the video and give this a try and see what happens when you do this. All right. So hopefully you've done this, and hopefully you recognize that what we need to do is realize that g of x is the same as y, and then plug in 0 over here for our x's. And when we plug in 0, once we simplify this, y is already by itself and we'll be good to go. When you simplify it, like we talked about in the last problem, you have to do the top. So 5 times 0 is 0, plus 1 is equal to 1. And then you have to do the bottom. 0 squared is 0. 2 times 0 is 0. And 0 plus 0 is 0. So I end up with y equals 1 over 0. But if you try to simplify this, well, it doesn't, right? Remember maybe in pre-algebra or something, you learned the little trick with fractions. If you have a 0 in the top of the fraction, that's good, right? That's somebody who's happy. This is like water. His head is above the water. He's swimming. He's having a good time. Life is wonderful. But if the 0 is below, if this was water, this person not happy at all, right? You can't be down there. You can't be down there. That's not a good place to be. So this is the kind of problem we can do. 0 divided by 1, that equals 0. But this is the kind of problem that we can't do. You can't divide things by 0. Okay, so that's just a quick reminder of stuff that you probably already remembered from pre-algebra. But bottom line, that's what we have here. We have a situation where we're dividing by 0, and you can't do that. There's no solution. So what I have is a situation where there's no solution for y, so therefore there are no y-intercepts. This particular function has no y-intercepts, okay? And in fact, if you were to go back and do stuff like we did earlier in this week, you would find that the y-axis turns out to be one of our asymptotes. So there's a vertical asymptote at x equals 0, and that's the reason why we can't cross the y-axis. All right, so that's y-intercepts. Here's an example in example number 1 where there is a y-intercept. And here's a situation in example number 2 where there's not a y-intercept. And you can definitely see both of those scenarios. So let's move on now to x-intercepts. Okay. Now, again, with x-intercepts, we already know the basic idea for how to do this. You plug 0 in for y and then solve for x. And we've done that many times. And in fact, we've already seen when we worked with quadratics and parabolas, we've already seen situations where sometimes functions do not have x-intercepts. So this is something we've done before. We're very familiar with this. So I think for this, we're going to just do one example. So I guess this would technically be example number 3 right now. We'll just do one example, and I think that'll be enough because we've done x-intercepts quite a bit in the past. So let's find the x-intercepts of this function right here. There we go. We're going to find the x-intercepts of that function. Oh, that's just a parabola. I need a fraction. Sorry about that. And then my other one is going to be 2x squared plus 7x minus 1. There we go. 2x squared plus 7x minus 1. So there is my function. Now we're going to plug 0 in for y, which remember this is the same as y, and we're going to solve. And one thing that might happen right here is you might be like, oh, holy smokes, I don't remember solving equations that are this big and nasty. There's just a lot of stuff going on here, okay? And we did solve equations like this last year. And we solved last semester, and we did it by using the cross multiplication method. So remember this number over here, any number you can write it as something over 1. So if you take it as 0 over 1 and you cross multiply, but look what happens when you cross multiply. 1 times that great big giant polynomial. Well, what happens when you multiply by 1? Nothing. You just get that thing. So I get 1 times that thing. That's just that thing. So I'm going to get a 2x squared plus 5x plus 3 when I multiply that by 1. And then when I cross multiply this way, what happens when I multiply something by 0? Well, I just get 0. So what's going to happen every single time we do these problems is because the way I solve rational equations is by cross multiplying, and because I'm going to be cross multiplying with a 0 and a 1 every single time, because you always plug in 0 for y. So this is always going to be a 0, and then you always just make it over 1 so you can cross multiply. So this is going to happen every single time we do these problems. So what a lot of people do is they just recognize if that's always going to happen, then I can just start right here as a shortcut. I can just start right here. So technically, plugging in 0 for y is what we do with everything. And technically, that still works here. But as a shortcut, I can just start right there and just make the top. Notice that that's what this is. It's just my numerator. Just make the numerator equal to 0. Instead of setting the whole fraction equal to 0, set just the numerator equal to 0. And solve. Now, if that feels like just one too many things for you to remember, then just do it the way we've always done it. Plug in 0 for y, cross multiply, and you're going to end up with that sooner or later anyway. Okay, so that's fine to do this work, but it's also fine to just start right there as a shortcut. Both of them work. But bottom line, where we're at is this equation and needing to solve that. Okay, so this is something that does factor. I can factor this, and if you're comfortable with factoring, you should do that. But in the last couple of videos, I've done a lot of factoring, and I do know from experience and from talking to students at school and such that some of us, we feel factoring is a little bit shaky, and we would rather use quadratic formula. And so since in the previous videos this week, I've done a lot of factoring, this time I'm going to use the quadratic formula instead, just as a reminder. All right, so remember for quadratic formula, the first thing you want to do is find your A and your B and your C, and those are already in order as long as you're in standard form, which this is. So A equals 2, B equals 5, and C equals 3. And then the quadratic formula says x will be equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so when I plug in the numbers that we've got here, b is equal to 5. So I'm going to get the opposite of 5 plus or minus the square root of 5 squared. And then a is equal to 2, so minus 4 times 2, and c is equal to 3. So 4 times 2 times 3, all divided by 2a, and we said a was equal to 2. So there we go. And remember, when we do quadratic formula, the stuff inside the square root, that was called the discriminant. We simplify that stuff first. Okay, so you can do that on your calculator. Maybe you can just do that with order operations right in your head. 5 squared, that equals 25. 4 times 2 is equal to 8, and 8 times 3 is equal to 24. So I've got a 25 minus 24. Well, that just equals 1, right? That just equals 1. And the square root of 1 is just 1. So that takes care of my discriminant. Now, I still have this plus or minus sign, and out in front, I've got the opposite of 5. Well, the opposite of 5 is negative 5. So that means I've got a plus or minus negative 5 out in front. And then down here in the bottom, I've got a 2 times 2. 2 times 2 is equal to 4. So for all of these, I've got a 4 down in the bottom, right? So there is my quadratic formula. And then remember, for this, we do 2 problems. We do one problem where it's -5 plus 1 over 4. So -5 plus 1 would be -4. So that equals a -1 when I do that. And I do another problem where it's -5 minus 1, -5 minus 1. So -5 minus 1 is -6 over 4. So that gives me a -3/2. So those are my x numbers. Okay, so what is it that we just found? Well, these 2 x numbers that we just found right here, these 2 x numbers were the solution to this equation. And where did that equation come from? That equation came from, well, either doing the shortcut or doing the cross multiply, whichever way you're going to prefer, for this function when we're trying to find the x-intercepts. So these 2 numbers that we just ended up with, what are these 2 numbers? These are the x coordinates of our x-intercepts. So the x-intercepts are a -1, 0 and a -3/2, 0. So those would be the points where we cross the x-axis. All right, so that takes care of everything. Oh, I do maybe want to go back real fast. On example number 1, notice I did not write this as an ordered pair. That's my y-intercept, but my ordered pair would be, remember, 0, -5, 12. Okay, so don't forget about that. So like I did. All right, so I think that takes care of this particular video. We've reviewed x-intercepts. We've talked about y-intercepts. We talked about that x-intercepts have a shortcut that goes with them that you're allowed to use if you want to. Y-intercepts, for the first time ever in our class, it's possible that they'll have no solution. And we've talked about all those things. So that's about it for this video. Thanks for watching. Have a good one.